My name is Tallard, and I'm participating in the 2014 Challenge program for Juritech, and I'm here to solve a Math 2000 problem. So for this Math 2000 problem, it's going to be divided into two parts. The first part is going to be determining the basis for the column space for this matrix, and the second part of this problem will be determining the basis for the null space of this matrix. So to get started with the first part, I need to understand what a column space is. So column space is a linear combination of all columns, which uses each column of the matrix as a vector. In order for me to determine what the basis is, I need to consider the independent columns. In order for me to determine what the independent columns are, I need to find out what the pivotal columns are for this matrix. And to do that, I need to reduce this in form of echelon form, or row echelon form. So to start things off, I must find out what the first non-zero element is for the first row, which in this case is the 2 for this first column. So for me, I know for the next step, I need to reduce the other non-zero elements of this column to 0 and use row operations to reduce it into 0. So I use the pivot, and I first set row 2 equaling the pivot times 4. So 4 times row 1, and add that to row 2. And to make things more short, I'm going to reduce the third row as well. So third row is going to be set equal to -2 times the pivot row for the row 1 plus the third row. This is going to give me a matrix of 2, 3, 4, -7, 0, 12, 3, 16, 6, 4, -28, 19, -9, and then the third row will be 0, -2, -6, -9, -2, 8, -18, -2, 14, 27. Okay, so now for the first column, it's been reducing all of the zeros. So now we can move on to the next non-zero element for the next column, which in this case is the 3 over here. So to reduce this in echelon form, I must reduce all non-zero elements beneath the pivot, or non-zero pivot that I just selected here. So I'll set the third row equaling the pivot row, or second row, times 3. And add that back to row 3. And this is going to give me 2, 3, 4, -7, 0, 3, 6, -9, 0, 0, 0, 0. So this is now reduced echelon form, and right here is my 2 pivots, and since these are my 2 pivots, these are my 2 pivotal columns, and from here we can now determine the basis for the column space for the matrix. But these 2 columns aren't going to be used as basis, since these 2 have zeros within the columns, which is not going to be the same space as it will be if you use the original columns from the original matrix. So the basis for column space is going to be the set of these 2 column vectors, which is 2, -8, 4, and 3, -9, -3. And since this basis has 2 columns, 2 pivotal columns, then this means the geometric description for this would be a plane, which would have 2 vectors from one point extending outward infinitely within the space. And this is the solution for this part. So now we're moving on to the second part of the question, which is finding out the basis for the null space for the matrix. And to do that, we gotta use this system of equation, which is the matrix times the vector equaling 0. In order for me to continue with the problem, I need to write this form into a matrix, and I have to write this using an augmented matrix form where I will use an augmented column of zeros to my original matrix. So this would look like 2, 3, 4, -7, 0, -8, -9, -10, 19, 0, 4, -3, -10, 13, 0. Okay, so from here, excuse me, I must determine what the dependent or non-independent columns are for this matrix, and in order for me to determine that, I must reduce this into reduced row echelon form. Since we've already reduced this original matrix in echelon form right over here, I might as well just continue for reducing this in reduced row echelon form, so it makes it everything easier. So let me just go over here and let me write this on top. So from here, we need to reduce this pivot 3, this column of pivot 3s with every non-zero element with 0. Have to change every non-zero element into zeros to having reduced row echelon form. So I would have the first row equaling -1 times row 2, and adding that back to row 1. That would be 2, 0, -2, it's -2, and 2, and then since we're using this equation here, we'll add 0. Let me just write down zeros over here, just so I can remember. And then it will be 0, 3, 6, -9, and 0, 0, 0, 0. Okay, now since we have these rows, in the same multiple of 2's, I can reduce the first row by dividing it by 2. So first row will be divided by 2, and the second row, they're all multiples of 3, so I can divide that by 3. So row 3 is equal to row 3 divided by 3. And let me just write this over here. So my answer, I reduce row echelon form will be 1, 0, -1, 1, 0, 1, 2, -3, 0, 0, 0, 0. And right here are my 2 pivots, and these 2 are the 3 variables. So now as in the reduced echelon form, I'm going to write this matrix in linear system of equations, system of linear equations. So I'll write it on the side right here, using in terms of 3 variables. Well, I'll just write it right here on the side. So this will be x1 minus x3 plus x4 equals 0, and x2 plus 2x3 minus 3x4 equals 0, and x3 equals x3, x4 equals x4, and there you go. And now that I have it written down as system of linear equations, I'll rewrite this in terms of the third and fourth column, which is x3 and x4. So let me write this down on bottom here. So x1 is equal to x3 minus x4, x2 is equal to minus 2x3 plus 3x4. x3 is still equal to x3, and x4 is equal to x4. So now that we have it written down in terms of our free variables, I can write this in a parametric equation form. So our x vector is equal to, well, let me first write down, since these two are our free variables, I'm going to assign x3 to s and x4 to t. So I can write it down in parametric equation form. So in here, our x vector will be equal to s times the vector of 1 minus 2, 1, 0, plus x4 and t of minus 1, 3, 0, and 1. So this right here is a linear combination for these two vectors of space. So these two vectors will be within the set for the basis of the null space for this matrix. So the final basis for this null space will be vector 1, negative 2, 1, 0, and vector negative 1, 3, 0, 1. And the geometric description of this basis, since there's two columns, this means this is a plane in the second R dimension. Oh, and excuse me, from the previous part, I forgot to describe that this plane here is also in the second R dimension. And that's the two answers.